The Gini index is a measure of income distribution, specifically the equality of income distribution. Looking at the graph we have presented here, our x-axis represents the percent of families. Our y-axis represents the percent of income. And the line that we have graphed here is y equals x. That represents the curve of absolute equality. We call it that because when we look at the xy pairs that make up this graph, we would see that 0.8 or 80% of families have 80% of the income. 40% of families have 40% of the income, and so on. 20% of families have 20% of income. That is referred to absolute equality in terms of income distribution. The opposite of that would be the curve of absolute inequality, which is basically a horizontal line following the x-axis. In a scenario like that, essentially one family would hold all of the income for a country, a state, a region, whatever kind of geographic area we're talking about. This rectangular region that we've just sketched out, bounded by those two extremes, forms a triangle, meaning it has an area equal to 1/2 times the base times the height of that triangle. In this case, the base of that triangle is 1 unit, the height is 1 unit, so the total area under that curve is 1/2. Meaning if we had a case where we had absolute inequality, the total area under that curve of that line y equals x would be 1/2. Generally what we see is something that falls, some curve that falls in between those. A curve that we refer to as the Lorenz curve. So the Lorenz curve is calculated based off a specific state, country, geographic region of some sort, using data that's available, and we'll get something typically of the form y equals a times x to the n power. So we'll calculate some Lorenz curve, and then to establish the Gini index for that geographic area, what we'll do is calculate the area bounded between that curve of absolute equality and the Lorenz curve. Meaning we'll find the definite integral as x goes from 0 to 1 of x, that curve of absolute equality, minus that Lorenz curve, L of x, or a times x to the n, whatever form that Lorenz function takes, dx. As that Lorenz curve gets closer to the curve of absolute equality, that area gets closer to 0. As it gets closer to the curve of absolute inequality, that area gets closer to 1/2, meaning this result will be somewhere between 0 and 1/2. And then just for the sake of simplifying and kind of, I don't know, making this a little bit more accessible, what we do is multiply that area by 2. So we take this integral and multiply it by 2. And what that does is has our total area range between 0 and 1 rather than 0 and 1/2. Just makes for a more relatable scale. This formula, once calculated, gives us what we refer to as the Gini index. Again, that value will be somewhere between 0 and 1. As we get closer to 0, That means that Lorenz curve is closer to that curve of absolute equality, meaning the area is smaller. We have more equality. As that Lorenz curve gets further away from the curve of absolute equality, we get a value that's closer to 1, which means less equality. In examples 2 and 3, we can look at actually calculating that Gini index for a given Lorenz curve. To do that, we'll need the definite integral tile. And we need to make sure out in front of that, actually I should have done this first, that we multiply by 2. We'll always take x and then minus whatever Lorenz curve we're given, in this case x to the 1.1, and evaluate that. In this case, we get a Gini index of 0.04761. And for example 3, we'll have exactly the same setup. All that changes is that Lorenz curve, which in this case will be x to the 9.12. And we get a Gini index of 0.80237.